5.1, number 13. We're supposed to find the Riemann sum R4 for the function g of x equals cos of pi x on 0, 1. Okay, so what to do is, without using a picture or anything like that, use the formula we had before. So R4, the right endpoint Riemann sum with 4 rectangles. So first of all, we know that n equals 4 in our formulas, right? That's the number of rectangles that we're using. Even though we're not drawing them, but conceptually that's what's happening, using 4 rectangles. And the delta x will be b minus a, so 1 minus 0 on that same n value of 4, so 1/4. So the abstract form I wrote earlier, the formula for this particular right endpoint was n equals 1 to 4, because in the right endpoint formula you've already moved 1 delta x in to get to that first right endpoint of the subintervals. So you would have f of a plus I delta x times delta x. Again, each of these is a height of a rectangle, and this is always the same base of the rectangles. And there should be 4 of them, and the first one should be happening at the starting point of the interval, 0, plus 1 delta x movement in. If you refer to the picture that I drew earlier, this will probably make a lot more sense than just hearing me say this right now. All right, so just to fill in all the pieces then, right, with what we have in the problem, R4, right, endpoint with 4 rectangles, for this problem should be sum n equals 1 to 4. F is cos pi x, so I need cos here, right, pi x. So this is the x it's talking about here, right? So cos of pi, and I need 0, right, for a, plus I delta x, 1/4. I just need to fill in the pieces, okay? So it's pi, let me just use a bracket here perhaps, so I have another parentheses here, instead of using nested parentheses, which sometimes looks more confusing to people. So pi, 0 plus I, 1/4. So I'll just go ahead and write the 0. 0 plus I 1/4. I'm going to write 1/4 I though. 1/4 I. Or I on a 4 would look nice. Yeah, like that. Times another 1/4 for the delta x on the end. So there. Again, write it just a little bit more nicely without the 0 there. Just write it first to see what's going on. But totally unnecessary. I'm sorry, I wrote in here. That's terrible. Oh my goodness. Yeah, that's ridiculous. I. All right, so I equals 1 to 4 cos pi of I on 4. Right? So let's just write that all in one shot then, like pi I on 4. I pi on 4 here, times another 1/4 on the outside. This 1/4 again you can bring to the outside. They write it here on the inside just so it looks more clear that it's a height times a base for each of these rectangles. Nevertheless, in practice, it's good to just take the outside because you can. It makes everything more efficient. So now I'm going to write it as 1/4 on the outside, and I'm going to start to compute these. I'm going to start to write this out. Okay? There's no great formula for this like we had for powers of I and things like that. It's just writing out directly. So bracket now, again 1/4 on the outside, because I know you can pull it outside the summation. And now the sigma will just go ahead and we're going to start writing out directly what these terms are. So from 1 to 4, the first one's 1 of cos pi on 4. That must be the height of the first rectangle. Plus cos 2 pi on 4, so cos pi on 2, height of the second rectangle. And now cos 3 pi on 4. And now cos of 4 pi on 4, which we cos pi. That's the height of the fourth rectangle. Each of these heights of the rectangles were multiplied by this base width of the rectangle, giving us really the sum of 4 rectangles, which is going to give us an approximation to how much area there is between this curve and the x-axis over this interval. Okay. So let's see what we get for the values. So 1/4 cos pi on 4 should be root 2 on 2. Cos pi on 2 is 0. Cos 3 pi on 4 should be negative root 2 on 2. All right, it's in the second quadrant. 3 pi on 4 is the second quadrant, and cos is negative in the second quadrant, but it has the same reference angle as pi on 4, so therefore root 2 on 2, but negative. So minus root 2 on 2 for the third one. And then the fourth one, cos of pi should be negative 1. Right? That's 1. Okay, so these two cancel, and that's nothing. So we get negative 1. So negative 1/4 is our approximation.